try not to be. We'll be able to do this whole thing, hopefully, without a calculator. All right, so here we go, simplify. You have options, always you have options, but you certainly have options on problems like this. Looking at homework, many of you seem to like the loop-de-loo thing, and I do too, it's great. So this kind of problem is loop-de-looable if you set it equal to x. If you set it equal to x, you can say 4 to the x equals 1/16. Remember, you always start with your base, so 4 to the x equals 1/16. Now in a minute, I'll show you how to do this without loop-de-looing, but I want you to know you can. For those of you that like to do it and are good at it, you can do all these problems almost with loop-de-loo. Maybe all of them with loop-de-loo. Now, here's the deal. If you loop-de-loo it, then you gotta figure out, okay, what power do you raise 4 to get 1/16? -2. Does everybody understand the power has to be negative? Because that's the only way to get 1 over. And since 16 is 4 squared, it will be -2. So the answer to the question is -2. If you prefer, you can do this problem by, from the beginning, changing the 16 into 4 to the -2. Because then all this cancels and the answer is -2. It makes no difference. Do it the way that you like to do it, that it's easier for you to do it. Both methods are going to require you to recognize that 1/16 is 4 to the -2. You're going to have to figure that out. All right, B. (11) to what power gives you 1? What? 0. 11 to the 0. So the answer to this problem is 0. Remember, the log of 1, no matter what the base is, the log of 1 is always 0. 11 to the 0 is 1. It's always 0. So if this were 12, it would still be 0. If it were root 17, it would still be 0. The log of 1 is always going to be 0. All right, C. Now, if you're going to loop-de-loo this one, and again, you can set all these equal to x, in other words, make an equation out of them, and loop-de-loo. You can do that with all of them. But if you do that, then the first thing you got to do is remember that 2 is an exponent. That 2, is that thing running, Jackson? Can you see it is? Yeah. That 2 is an exponent. So this is log base 3 of 81. 9 squared. So 3 to the x equals 81, and then you just got to know how many 3's times each other give you 81. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, so 4. So x is 4. Some of you have that memorized. If you don't, you have to figure it out. Now, when we did these problems in our notes, that same problem, and this is the last one I'm going to do both ways, because this is fine. If this works for you, do it this way. You can also do it by rewriting the 9 as 3 squared. So the log base 3 of 3 squared is 2. So this is 2. But that 2 is being times by 2, so the answer is 4. Either way. Hopefully one of those two ways makes great sense to you. All right. base 7 of 1 over the cube root of 49 equals x. 7 to some power is 1 over the cube root of 49. Does that make sense to you? Now 49 is not some random number. 49 is 7 squared. So this is 1 over the cube root of 7 squared. What exponent is this? Well, first of all, 1 over will be negative. And then the cube root of 7 squared. Nyla? 2/3. Remember, the denominator tells you what power, the denominator tells you what root you're taking, so cube root to the 2nd power. So the answer is negative 2/3. Now digest that for a second. Radicals are fractional exponents. A cube root is a 1/3 power. A square root is a 1/2 power, right? Since it's 1 over, it's going to be negative. And that's where we got negative 2/3. Does anybody need to ask about that? Something there not make sense to somebody. All right, next, log of 1,000. If we're gonna loop-de-loo this, we need a base. And we know the base on LOG is 10. So 10 to some power is 1,000. And the power is 3. Remember, the power means 10 times 10 times 10. That's log E. So I'm not going to rewrite it. I'm just going to put an E here because that's the base. So e to the x equals the cube root of e. Does that make sense to you? Well, what exponent is a cube root? I just told you. 1/3. So e to the x equals e to the 1/3. So x equals 1/3. Tying this into something we talked about last time, you have ln cube root of e, which is ln e to the 1/3. And you remember me telling you the other day that when an ln and an e are touching each other, they cancel? So we get 1/3. We got 1/3 when we move down here. Doesn't matter how you do it, the answer is 1/3. And how about G? Got a thought on G?
X equals
-7. -7. Because it says log base e of e to the -7th, doesn't it? Or if you rewrite it, e to the x equals 1 over e to the 7th, but 1 over e to the 7th means e to the -7th. So x has to be -7. However you do it, -7. Anya, does that all look good? All right, you ready to move on to number 2? Little logarithmic equation. Oh, the first one's easy. What's the answer to the first one? Square root of 17. Square root of 17 is the answer because when you loop this one. We have 17 to the 1/2 equals x. And we remember that fractional exponents are radicals. The denominator tells me which root. So this is the square root of 17. Very, very good. B is not so easy. Anybody remember how to deal with this one? This is a little bit more challenging.
If it's minus,
What?
if it's minus, it's m over n.
It's a division problem. So Peter says you cannot solve a logarithmic equation that has more than one logarithm on the side. That's not possible to solve. So we have to smush it so that we end up with just one logarithm. So we somehow have to put these two back together. Someone has pulled them apart. We gotta put them back together. Peter said when that's a minus, they'll go together as a division, a fraction. So inside here, I'm gonna have x plus 2 over x. If that had been a plus, then when I put them together, it would be a multiplication. When you put them together, you're either gonna divide or multiply. That's it, there's only two options. And that depends on whether these are added or subtracted. Now, can I loop-de-loo it at this point? Yep. So 3 to the first equals x plus 2 over x. What's 3 to the first? 3. How do I solve something like this? So 3x equals x plus 2. Subtract x. And it looks like x equals that problem's a little bit more complicated than any of the others we've done today. Does anybody have a question about that?
There was multiplication of the FOIL.
Yep, you distribute, it'd be x times x plus 2, yep. So it'd be x squared plus 2x. All right, number 3. Got a little exponential equation. This is an exponential equation. A times b to the x. Does it represent growth or decay? Why? Decay is right. Why? Because the number being raised to the power, the 0.73, is less than 1. How much less than 1 is it? 0.27? So the answer to B is 27%. The answer to B is not 73. The answer to B is how much less than 1 is 0.73. It's less than 1, how much less than 1? Everybody got that? 27% decay. What's the initial value? 130, yeah. So whatever it is we're measuring here, we started with 130 at them. All right, simplify. Anybody misses this one, I'm gonna get so mad at you. What is the answer? 3 over x to the 4th. 3 over x to the 4th. Some of you missed that in your homework. Ugh. Only the things with negative exponents go to the denominator. So the 3 stays. What about this? There's a lot to be done here. And truly, the older you do it, doesn't matter, but I think there is kind of an I think there's an easy way and a hard way to approach it, but there's no right and wrong way to approach it. What occurs to you? Lauren?
Would you multiply the exponents by 2/3?
Okay, so you want to apply, this guy right here goes to everything inside, including the numbers. We could start out that way. Now, what that's gonna do, Lauren, is fill my problem with fractions that I'm gonna have to deal with. So that will 100% work, 100%. I think it's easier to clean this up first and then apply. So I'm gonna have my 8/27. Now when I say clean it up, this will come to the bottom. Would you agree with that? So that's gonna be x to the 12, because there's already 9 down there. Now, it's cleaned up. So now I have to do what you said. I have to take everything to the 2/3 power. Now, 8 to the 2/3. That is not 8 times 2/3. That's 8 to the 2/3 power. And what does that mean? 8 to the 2/3. It's a radical. Cube root of 8 squared. So that's going to be what, 4? While I'm at it, I'm going to do the 27 because it's the same thing. 27 to the 2/3. I'm not multiplying, I'm raising to a power. So 27 to the 2/3 means cube root of 27 squared, 9. Now, did everybody catch that? We're taking these guys to this power. That's a fraction, it means a radical. Now, these guys, these are both exponents. So I'm gonna go ahead and multiply them, so that's gonna be y to the 10/3. And x to the same thing, only that'll work out, that is what, 8? 12 times 2/3. And there's my answer. At some point, the x's have to be combined. I like to do that first. It minimizes my arithmetic. But you don't have to. As long as you get them combined at some point, you're all good. Anybody have a question about that? Well, on this quiz, this was a bonus. This may or may not be a bonus for you. It may be a required problem. Because you guys are smart. You can do this. Take a look at it and give me any thought you have. Because I'm noticing some stuff here. And I'm just
Divide by
wondering-
3.
Divide by 3?
Could you?
You could, but if I were gonna divide, I'm gonna go ahead and divide by 9. If I'm gonna divide. So I have 1/3 to the 2x minus 4 equals 9 times 3 to the x. Now you do not have to do that. Sometimes we have to. We don't in this problem. But it simplified things a little bit, right? Carol?
Couldn't you do something with like 3 to the x and make it into a 1/3, or would that not work?
That would absolutely work, but I'm gonna challenge you a little bit on that. I've got a 9, which is 3 squared, and a 3 to the x. It might be easier to change this into a 3. So what is 1/3? 3 to what power? -1. Do you understand what Kara's doing here, you guys? She is making all of the bases the same number. happens to these right here? What operation? Multiply. So 3 to the negative 2x plus 4, I'm multiplying here. What happens over here? What happens to these exponents? Added. And that has to be done. You, remember a minute ago you couldn't have 2 logarithms on the same side? Well, you can't have 2 of these on the same side. You gotta get them put together. Now they are. And as soon as I do that, as soon as I have 3 to this power equals 3 to this power, what happens? The exponents are equal. So negative 2x plus 4 equals 2 plus x. So it looks like 3x equals 2. Did you get 2/3? Check my arithmetic. Did you get 2/3? Now, I just want to back up 1 minute, and we're going to get ready to go to lunch. I want to back up 1 minute here. The next problem you see, you may not be able to divide so nicely. We could have approached this problem just fine without dividing, because 9 is 3 squared. And 81 is 3 to the 4th. Then these would have been added, so negative 2x plus 6 equals 4 plus x. Add these exponents, add these, and look what's going to happen. Aren't I going to get exactly the same answer? So it was great to divide it less than some of my other arithmetic. Van, I am absolutely going to rip your head off. Okay, you're the one that had this great idea, and now you're on your phone. Okay, that's an infraction, and the next time I'm taking it, all right?
Sorry.
Yeah, you're going to lunch in a few minutes. In fact, you'd probably already be there if you hadn't made me nap. All right, does everybody get that the idea for this problem, because this might not be a bonus for you, hint, hint, hint. You gotta get a common base. Might not be 3, it might be 2 or 5 or something like that, but you need a common base. Okay? All right, now just time out a minute, I can't let you go too early.